Let's get playing. We're gonna unbox our Beebots with Chris.
All right, guys. So I have not unpacked. I have two. This one I just kind of have been looking at it and it's staring back at me. I'll put that one aside. But I have an unboxing. All right. So we'll start right from scratch. We'll open it up. I'm going to show you the various aspects of it, and then we're going to play with it. We'll actually do some activities together with the Beebot. But I'm going to look at the basic one, the Beebot. They come, in singles, or you can get them in a bigger kit. If I think they come in fours as well, with like a sitting station where you put them on the station. But this one is just a single, and inside I have like a cord. This is a charger, just to give it juice. Remember, all of these things require power to function. And then I have the bot itself, and then inside they also give you a little user guide. So, now, the Beebot. When I pull it out, again, it's very basic, right, guys? So it's all directional, or you're basically using directions to make it function. And I can do short programs, or I can do really big programs. But I don't need to attach this one to a computer or a tablet or anything. I can just do it all right here, which is super fun because the kids get immediate feedback from the robot if they're having success or not. This is particularly interesting when kids are figuring out left and right. I should say right and left. And you'll start to see that they'll discuss, oh no, you went left, you went right when you should have went. So these rich conversations start to take place when the kids are interacting with it. So on the top, I have my directions. The green button is to make it go, is to make it do what I've said. The pause, I can always pause it if I just want, say there's a teachable moment going on, I just want them to stop the program, just hit pause and it just stays where it was at. It'll resume the program once you hit unpause. And then the X button, or the reset, is to just clear its memory and start over again. And that's a really handy thing to have. Now, if we flip this little bugger over, we can see that it runs basically on two wheels, right? And the wheels, the turning typically, and the kids might want to watch this, it's quite interesting, is that when I want to turn, one wheel turns off and the other one moves, right? So depending on what direction I want, one wheel will stop, the other one will move, which will allow direction change, which is kind of cool. So it's two wheels, that's it. There's no sensors on this. You can see there's a speaker because it does this weird buzz, but thank goodness we can turn it off, because if you have 4 of these or 5 of these going at the same time in class, it can be a little annoying. So in the middle, this is our power button. So this gets it going. And then I do have power for the things that I don't want on, like sound. If I want to turn the speaker off, I can. And also the buzzing it makes, these lights as well, I can turn off. But typically I usually turn everything on. So if you want to just turn your Beebot on, and you'll see right away it lights up, its eyes will light up. Now, the battery detector you'll see is the eyes turn red when the battery's low. Okay, so you'll know when to charge it with your trusty power cord. Now, one other thing which I find super interesting, I'll just add, is this little tail. So I can create a little parade if I want, because I could hook, say I want to hook a little carriage on it. I could hook a little carriage on it and have the Beebot carry stuff along with it. Or I could have a little wagon, and as it goes through a story, it collects things. All different kinds of ideas, but that little hook's pretty cool. The hole there too is also really cool, because then I can start to, you can see on my desktop, I started to make lines with it. So I just took a marker, and this is kind of a fine point marker, and I was able to just set it in there, turn on the side, and then it could drag it and create lines and stuff, which is really fun. The kids love that. It's kind of like you can turn it into an art bot if you want. Now, you're not getting dramatic things. You can see on my desktop, there's nothing dramatic here. It's a couple lines. You could also see that you see its tail as it turns. So if it's dragging the pen and it turns, it kind of creates this 1/4 arch kind of thing, which again could be something you could talk about. Why does it do that and stuff like that. So simply, you're just pressing a button, you'll hear the click, and then you hit go, and it goes. And that's the annoying thing it does. At the end, it'll always go beep, beep, beep. So if you don't want it to do that, you can always turn it off right here with this switch right here. All right, we'll turn it off. All right, let's play. All right. So our first challenge, we're going to give you a series of challenges, and we'd like you to do these, and then we'll kind of chat about them after we've done them. So our first challenge is, it's called Feel Like Dancing. So program your Beebot to dance. So things you can include are a couple of little spins, maybe a shuffle. Again, you can play around with just the buttons to create some kind of sequence. And record your dance sequence for others to try. Like, this is another, we might not get to that part, but if you wanted to challenge your kids, your students, then they could then take their iPads or their phones or whatever device you have, record it, and then the other kids have to try to duplicate it. They could also write it down, right? So I could say, okay, well, you got to go forward 2, and then I want you to turn, and then I want you to move 2, and then you're going to turn again. Okay, so they could actually make out the code as well, just on paper, before they've even touched to have the kids create patterns, shapes. This is particularly interesting if you want to attach a pen to it as well, because then they can actually see the patterns being created on paper that they're playing on. But it's also just good for them to start thinking about logic. Like a square is 4 equal lengths. And basically, I'm always doing a quarter turn as I go through. So if my logic serves me right, if I wanted to make a square, I would go forward, I would turn, I would go forward, I would turn, I would go forward, and I would turn. Is that 4? Well, let's test it, right? That's the great thing about this, is I can test it right away. There we go. Right, so, oh, right, I did the wrong turn. Okay, so again, great examples of, failing, like not having it right and then having to figure it out. The debugging part is when you get other people to come in and collaborate. So say you gave one Beebot to 2 students, you can assign them different roles, which we're going to talk about, so that problem solving is just embedded in this. They're not even going to realize it. A lot of these skills that they're going to just naturally come out, the collaboration, it's not, you're never going to have to say to the student, hey, you guys, can you go and collaborate? They'll just be like, can we have the bot so we can go and play, right? I mean, that will be their reaction to it, rather than, oh, we got to go problem solve, right? To them, it's just play. So the great idea is for you as well, I think, as a teacher, when you're first showing them, is to make a few mistakes on purpose, to show them that mistakes are so important in figuring out how these work. We always learn through our mistakes, and we need to make sure that our kids start to embed that internally, that mistakes are super important, unlike what they're going to face when they get into high school, unfortunately. But we could at least get them a little bit on the right path to start. There is our shapes, all right? Hopefully you guys were able to figure a few of these out, giving roles to kids, because you're probably not going to have a one-to-one, right? So assigning roles to kids gives them a sense of that they're involved in the process, and then you can just switch these roles around as you go. The designer helps to create or read the challenge that you've given or that they want to create, and then challenge another group. And again, they record this, right? So they're kind of the recorder of the direction. Similar, if you have cards like Craig's going to show you in a minute with arrows, they could have those to kind of help with the navigator to make the program. So again, collaboration would happen naturally without you having to say much. The navigator plans the program using the cards, ones that you make, or they could do it on paper is fine as well. And then you have the driver. The driver is always a fun role for a bit. I'll say that. The driver typically likes to drive a couple of times, but then they're like, well, I want to build a program, right? So they're happy to go to navigators once they've driven. And if they all know they're going to get to touch the thing, then they're happy with it. And then the debugger is when you run into an error. Well, where is it? because sometimes kids won't see it, right? If they get really into it and they're thinking about it and they have an oversight of something, it takes another set of eyes to kind of see where that error is. So it's always good to have two people on one of these. I recommend having 1-to-1 on these. It limits the skill development and the collaboration, the problem solving. I mean, they'll do that, but it's very insular. Whereas when you're getting more than one involved, right? So you have 2 kids, 3 kids, then all of those skills have to come out because they have to socialize and work with each other.
A mat possibility and making a board to follow. So I'll hold that one up for you guys to see. So these are those squares, right? Those 15 by 15 squares. And I use the alphabet. You could use numbers. You could use anything, right? Even mapping out your school or the neighborhood around the school. And you can see my vowels. I use different colors for the vowels, so we could talk about that. And then the consonants are another color altogether. This is the size that we're talking about, but I like the example before of even a line, right? You can just have a straight line and put them in sequence and then do an angled line, and the Beebot will follow that. It doesn't have to be a tile like this, but that's what we had done for this thing. And when I was talking about mapping out your school, you can use creative, colorful things to represent parts of the school, right? The library, principal's office, where we all want to go for sure, the gym, the cafeteria. There's an art project for your students, you can be creating the tiles. They could be responsible for making tiles for your outdoor environment, for in your school, that kind of stuff. And so the sky's the limit. You can do a map of Quebec, a map of Canada. And you can see in the images on the slide, there's some rainbows in there. So there's a whole story possible to look at.